Hello my dear students, welcome to Fluid Mechanics lecture series. I am your Sumam. Today we are going to discuss about fluid property, that is vapor pressure and cavitation. It is well established that pressure and temperature are two dependent property for a pure substance is concerned during its phase change process, and there is one-to-one correspondence exists between these two properties. For example, if you are keeping temperature constant and the pressure under which a substance is undergoing a phase change, that is called saturation pressure. Similarly, by keeping the pressure constant and the temperature at which the substance is going to phase change, that is called saturation temperature. Now comes to vapor pressure. Vapor pressure is the pressure that is exerted by the vapor. It is the property of the pure substance. So vapor pressure is defined as the pressure exerted by the vapor when it is in phase equilibrium with the liquid at a given temperature, and it is different from partial pressure. So partial pressure is defined as the pressure exerted by vapor or gases when it is mixed with other gases. For example, atmosphere consists of water vapor and air. So that means atmosphere pressure equal to the summation of the partial pressure exerted by air and partial pressure exerted by water vapor. So in normal condition, the percentage of water vapor is very less, and the major components of air, that is oxygen and nitrogen. So atmosphere pressure equal to the summation of the partial pressure exerted by water vapor and partial pressure exerted by oxygen and partial pressure exerted by nitrogen. The partial pressure of vapor is less than the vapor pressure, or it is equal to the vapor pressure if the liquid is not present. If both liquid and vapor are present in a system and the system is in phase equilibrium, then partial pressure, that is equal to vapor pressure, and we can say that the system is saturated. Usually rate of evaporation process in large open water bodies is controlled by the difference of partial pressure and vapor pressure. Let me explain this with an example. The vapor pressure of water at 20 degree, that is equal to 2.34 kilopascal. If you are keeping water in a bucket and it is exposed to atmosphere in dry air condition at 1 atmosphere pressure, so the water is getting evaporated. After some time, the partial pressure that is exerted by water vapor, that is equal to 2.34 kilopascal, which is the vapor pressure of water at 20 degree. So that means at this stage, the difference of partial pressure of water vapor and the vapor pressure of water, that is equal to 0. So that means evaporation process will stop. One more thing regarding vapor pressure is vapor pressure that will be increasing by increasing the temperature. For example, if the vapor pressure of water at 20 degree equal to 2.34 kilopascal, but when temperature increases to 25 degree, it becomes 3.17 kilopascal. Let us see what is the importance of vapor pressure in the practical situation. Fluid is capable of flowing and it cannot resist the shear forces. So if you want to transport liquid from one place to another place, we have to pressurize, or we have to depend upon pump. Pump is used to lift the water or any liquid from one place to another place. So that means during pumping, we'll be pressurizing the fluid. So when the pump stops, or it may be due to the pump trip, or it may be due to the power failure, then the pressure in the flowing system or pressure of the fluid in the flowing system, that is getting down. So in that cases, when the pressure drops and when it reaches the vapor pressure of water, what will happen is vaporization will be occurring or phase change is occurring. We learned previously that vaporization that will be occurring by increasing the temperature by keeping pressure constant. Similarly, when the pressure drops and it reaches the vapor pressure, then also this vaporization that will be occurring. So because of this pump trip, pressure of the fluid in the flowing system, that is getting down, and it reaches the vapor pressure of the flowing liquid. So this unplanned vaporization occurs when the pressure drops below the vapor pressure in a liquid flowing system. So this can be explained with an example. So this is a pipe that is flowing with water. So in the normal working condition, the pressure of the flowing fluid is more or less equal to the pressure that is supplied by the pump. So when the pump trip, what happens is pressure in the system that is getting down. So when the pressure drops and it crosses the vapor pressure, what will happen is vaporization that is occurring. So that means water is converted into small water bubbles. We can call this as cavitation bubbles because it forms cavity in the liquid. So this vapor bubbles that formed, that will not stand still there. It is carried away by the flowing liquid when the pump restarts. So these vapor bubbles are carried to the places where the pressure is higher than vapor pressure. So at that places, when the pressure increases beyond vapor pressure, these vapor bubbles will collapse and it releases large amount of energy. So this unplanned vaporization occurs when the pressure drops below vapor pressure in a liquid flowing system, and these vapor bubbles collapse when they swept away from low pressure region and when it reaches the high pressure region. So when this collapse occurs, it will generate highly destructive, extremely high pressure waves. So the generated pressure is many times higher than the working pressure of the pipe material or the hydraulic component. So what will happen is the system will fail. So this phenomena is called cavitation. So what is the importance of this cavitation in the practical field? Cavitation can affect the performance of hydraulic machinery such as pumps, turbines, propellers, and to be prevented from the hydraulic system. So the pressure hikes resulting from large number of bubble collapse near the solid surface over a long period of time cause erosion, surface pitting, fatigue failure, and erosion of turbine blades. So this alternate vaporization and condensation that is occurring periodically in the flowing system. Generated pressure is many times higher than the working pressure of the material that is used. In that cases, this bubble collapse near the solid surface, that is erode the surface or it will weaken the surface. In the case of turbine blades, the tips of the blades are getting eroded due to the collapse of this vapor bubbles. When the turbine blades are getting eroded, that will be affecting the rotational speed of the turbine. What is the purpose of turbine? The turbine is used to convert the energy of water to electric power. Generation mainly depends upon the speed of the turbine runner. So here, when these turbine blades are getting eroded, then the speed of the rotation that will be get reduced. So that means power generation is getting reduced or the overall efficiency of the hydropower plant that is getting reduced. This figure which indicates the erosion that is taking place in the turbine runner. It also causes destruction of components of machinery and it generates annoying noise and vibration. So this cavity collapse which gives large amount of noises and the pressure that generated due to cavity collapse will vibrate the entire hydraulic system. So that means overall performance of the hydraulic system is get reduced due to cavitation. The pipe material cannot withstand the high pressure that produced accompanied by the vapor collapse. So that is also getting collapsed. And in the case of water distribution system, the entire water distribution that is getting interrupted. So vapor pressure and cavitation is a destructive phenomena and that to be prevented from all our hydraulic system. So to conclude, we can say that in any flowing system, if the pressure at any point in the liquid approaches the vapor pressure, vaporization of liquid starts, resulting the release of dissolved gases and vapor. So the bubbles of vapor thus formed are carried away by the flowing liquid into a region of high pressure where they collapse, giving rise to high impact pressure which are very strong enough to erode the surface. So this phenomena altogether we can call as cavitation, and cavities are formed or it is able to break the system itself. So it is a destructive phenomena. So this figure which shows erosion that is taking place across the turbine runner and runner blades are also getting disturbed or getting eroded due to this cavitation. So as a practical engineer, we have to prevent the occurrence of cavitation. So with that, I am concluding. Thank you.